make good predictions. And it takes a lot of prep work up front to get all of that ready. But for a lot of tasks, it can't. For discussion, anyone want to jump in? Yes, only as true stats, not easy stats, apparently. I'm fine with balance. I can give everybody a minute to think about it a little more if you want. Or we can jump into the fun part.
Time saving, which I think for me is like, in my mind, where I draw the line between like physical or scientific modeling and AI or machine learning modeling. The former is focused on kind of understanding and developing like human interpretable knowledge, and the latter is more for like saving human labor and not really caring about understanding how it did it. So there's like, yeah, some kind of continuum there. But
yeah, there definitely is. So there's a term that we'll talk about in a little bit too called explainable AI, and it's a big part of the AI movement where people are trying to move our understanding of AI out of the black box idea and to say, you can do a machine learning model and it's not just a black box. You can dive in and you can see what's going on. And yes, there's going to be randomization and things that you can't, just predict on your own, but you can understand how it's functioning. You can dive in and I think just saying, we've got a bunch of data, here it is, and here's a model that we've prefabbed, and it's just some black box we don't really understand, but we put the data in, and then some stuff comes out, and ta-da, we're done. I think that's really problematic because as with any model, there's a lot of decisions to be made, and so you want to make sure that your data prep is correct going in, and that you're making the right decisions about the model itself in order to get something that is actually. But I'll get off my soapbox.
I feel like that can be said for like stock synthesis, right?
Yeah, exactly. Yep.
But because AI is perceived as being so unbiased, like the machine's doing all the thinking, that there's that.
Yeah, and I think that's a really important point to bring up. And I have a section at the end, but maybe we can jump into that for a minute. At the AI workshop that Noah hosted last fall, we actually had a discussion about ethics in AI. What does that mean? What does that look like? And one of the topics was bias. Do we use data if we know that there is systemic bias in the data? I mean, is it okay to use that data? Or if you do use it, what do you do with that? How do you talk about that? How do you make folks aware of the fact that there is systemic bias going in, and that's sort of a known factor? People usually get uncomfortable at this point. It's fine. Christine, you should be able to talk now. Oh,
I think this is polarizing, but I don't think we can throw out all of the bias data because there's always going to be some bias. I think we model the bias. Well, ideally you collect more data that counteracts the bias, but if you can't do that, I think it's still useful, even if it's biased, but you have to be aware of it and somehow model or account for it.
I agree with that, and I think we have a lot of work to do in getting towards documenting where our data comes from and if it includes bias and what that bias is and how it's going to affect the entire process of data going in, modeling, information. One of the examples that I go back to is beach user access, and they have video camera data for some of the beaches along the East Coast, and they document who's using the beach and at what frequency and for what activities, right? But there are different access privileges at different beaches. There are some beaches that people don't go to because they don't feel safe there, right? And so there are a lot of factors that go into that besides just someone showing up at the beach to do some activity. Yeah, you can if you want. And I think, you know, we all observe the world through the lens of our own experience, right? And so maybe the data collection process is biased just by the nature of the person who initially designed it and the way that they saw the world and thought data should be collected for a particular system. And a lot of times we use data in different ways now for different things, but sometimes we've got really long time series and they were designed for something other than what we're using them for now. How do we deal with that?
Refer to it as an unbiased data set.
Right, exactly. Exactly. So there's no such thing as unbiased AI because there's always some kind of bias somewhere in data, right? And we don't have AI. We don't have tricky. All right, should we go to another section? Talk about all right. So here, I've been thinking a lot about AI in fisheries management and in conservation, and I tried to sort of break it down into three main groups based on how I see things, obviously through my own lens. And so I just want to define those three things. Here. So, prediction, and then categorization. All right, and then the last one, classification. So for prediction, what I mean is we're trying to do something along the lines of point estimates. We're trying to predict some sort of specific value. In categorization, we're trying to fit into a box. Maybe we're above or below some threshold. We're in some field, for example, here. And then for classification, this I think of as you're identifying something specific. So, for example, you're doing image identification, maybe audio. You're looking for specific thing in your data to pull out to make your data processing faster. So I've got some examples, but I would love to hear from folks online, you know, what types of machine learning you either do or want to do or think about doing in any of these categories. So I can fill them out a little bit. And I've thrown together, let's see, examples or things you want to try or problems you have.
Yeah, it's about prediction, like Daniel Mondo's work on salmon forecasting model, right? Like how many salmon are going to come back next year.
Yep.
That probably falls under prediction. I think I'm having a bit of trouble. I don't totally know what the difference between categorization and classification.
Okay.
Or like for example, global fishing box. Is that classification and ID? It's like fishing boat versus not fishing boat. Behavior. Is that categorization or classification?
Good question. I think that could potentially be categorization. That's a tough one. Good question. No, it's fine. So for categorization, one of the examples I think of is John Proctor's herring models, and he was trying to see if they were either recovered or not recovered. So that's a categorization. So there's a herring stock, and you look at the population biomass through time, and you say, is it recovered or not? Global Fishing Watch. So they track vessels and they determine if it's a fishing vessel or not a fishing vessel.
Then they also are like
Mm-hmm.
so that would be fun.
That's probably ID. Yeah. So yeah. So they're identifying types of behavior and types of vessels. Vessels. All right, shout them out. Let's see, we've got for classification, we've got have Cam identifying sea scallops. Yep. We've got happy whale. We've got analysis of electronic monitoring footage. Under categorization, we'll put classifying acoustic backscatter into type of animal. We got a new classification one of like camera survey data analysis. Yeah. Chris, do you want to shout out yours?
Sure. For how about species classification via using otolith?
That is a great one. Yeah. So looking at otoliths and putting them in an age category, right? Or class.
Yeah.
Class.
Yeah, like two species in separation by using otolith morphometric.
Mm-hmm. That's awesome. Yep.
Fishing boats, some of them now use AI to determine like what the best cut of fillet would be.
Whoa.
I don't know if that would be under categorization. Like maybe they sort the fish based on that too, but they can get a fish on their thing. Okay, cut here.
Wow. All right. That's awesome. I had not heard of that. That's cool.
I don't know if that's categorized. I know.
Yeah. You might have categories of fish.
And also like fish on.
So it's between, 10 and 20, 20 and 30. who's got the same spin. Yes.
Go ahead, Christine.
I don't know if this fits under one of these three or is a different one, but there's some folks using it for dimension reduction, like if you're trying to analyze oceanographic data or like a lot of complicated inputs into a smaller set of dimensions.
Yeah. That's sort of a data processing one. I tend to lump that through here, but yeah.
Chris.
Oh, sorry about that. I made a mistake in raising my hand. Sorry about that.
Oh, no problem.
Yeah. So, I mean, AI is great for this type of thing, dimension reduction, or, instead of listening to 700 hours of acoustics, training some AI to pick up the signals that you're interested in. Or instead of looking at years worth of benthic photographs, there's a couple of resources for benthic identification and coral identification.
Dimension reduction, it almost goes into categories like pattern discovery or clustering or like supervised.
Yeah.
And also implementing the edge AI, implementing the detection and classification on real time.
Sorry, can you say that again?
Means right now, the processing what we do in modeling is you bring the image and then you detect. But instead of doing that, you have to have detection when your camera is underwater. It will take images and it will start detecting the fishes and everything. So you will be loading your model itself on the camera. So you don't have to do, you'll be saving a lot of time. It's a real-time edge.
Yeah. Are you saying for like the habitat camera and things like that, you have to do a lot of image prep?
That's right, because now the underwater goes, you collect all the images, then there you do the data annotation, then you do the labeling, and then you perform the count. So all this can be reduced if we build and implement the model itself in the camera. So your camera will start detecting instead of, and it will also start labeling instead of doing the work, post-process work. So it will reduce the labeling, all those 6 months work to each dive. Just one dive, you got all the data with detection, with raw data.
Okay. So you're saying in one dive you get all of your data and then you apply it to the other?
Yeah, you can get all your data. You'll get annotated data, means which is already labeled, marked, and counts everything.
Nice. Yeah.
This is like right now what we're talking about is the edge AI, which is the AI on the device itself. Most of the AIs are on the cloud, or you run your models on the cloud, or you run your models on your data center. But the future is you are going to run the models on the devices itself. So it's called edge AI.
Wow. So you're training the camera to look for specific things.
That's right.
That's super cool. I don't know if I have a category for that. Maybe under here, but pattern discovery, I don't know.
No, I can show you.
There. Great. So yeah. Right. So getting off the computer and actually training devices to look for things.
Yeah. I have implemented. I can show you the demo for fisheries.
Yeah. How's it going?
No, I just did for proof of concept and demo. It detects the flat fishes and everything.
Wow. I think that's really cool. That's really cool. I mean, and that has a lot of potential applications in a lot of different fields, training devices to look for things.
Right. I mean, it reduces the data annotations itself because the model, like there are two ways you can annotate. The annotation itself, you can make it automation of the annotation. You don't have to do the manual annotation. Once you have set of data which is annotated, you can build the model on top of it. The next process is whatever images you get, they will come back annotated directly. So your annotation will also be reduced. And the thing what you can do is just do the testing and verification. So you don't have to sit and annotate 100 images, like every day one image. You send 1,000 images to the model, it will annotate, it will mark, it will do the bounding boxes,
Wow.
and it will the data to you.
You're sort of training it to do the data prep too.
Yeah, into the data set. Yeah. So I've shown this demo in a like AIML place, the monthly meeting. And if you guys are interested, I can show you how it works.
Yeah, I mean, this is great. This is a lot of stuff I haven't even thought about. That's why we're doing this here. This is really fun, and I think, you know, it's interesting to use AI to prep your training data set for AI, right?
That's
It seems like both a great idea and potentially some complications with that. You know, making sure you validate the data prep process correctly and thoroughly,
right.
but also that would speed up a lot of the analysis. Anyone else want to jump in on this discussion?
Another prediction one I just and for complicated machine systems, you can monitor a bunch of data coming out of it from different parts of the system and try to predict when it's going to break before it breaks. Like I've heard of this being done for like remotely operated vehicle where you have data streams about all its hydraulics and electrical systems and so on.
Great. Okay. Point in time, essentially.
Well, yeah, just like this combination of things has gone out of spec.
Oh yeah.
And like it's not broken yet. The cylinder hasn't popped and let in seawater yet, but like it's at risk of happening soon, so replace it, kind of thing.
Wow. Yeah. I think things would be great. Awesome. Really cool. One of the other categorization examples that I thought was cool is someone was using AI to detect outliers. And so they're doing, had a ton of data. Most of it was great. I think it was tracking data or tagging data. Most of it was great, but sometimes you get a ping that's just not right. Or sometimes it's a little bit not right, but it's hard to tell. And so training a model to sort of detect those outliers. And that can be part of the data process too. Looks like the board's filling in. We have a second board if this one fills up. What am I missing?
Climate prediction, like climate forecasting sort of prediction, like they use AI for that, or at least like right.
Yep. Okay. Also fire models. There's a lot of prediction based on a ton of variables when and where they think the fires they spark. That's a big one. Dynamic ocean management. Under prediction. Yeah. Okay. Okay. So there's one for limited amounts of data to predict, so we're that about predicting
Those
missing
are in the problem.
section. All right. Yeah, that is. I've got red marker for that.
Now, we got some problems being
Yeah.
identified for sure on that.
Yeah, let's talk about it. Let's talk about the problem. Limited data.
And like lack of curated training. They're saying the terminology is different from traditional.
Yes, and even within the field of AI, people use a lot of similar terms, different things, or the same terms to mean separate things. Yeah, so that's a big one. We got to figure out how to get on the thing. If that's a paper somebody wants to write, send me an email. I'll provide some suggestions.
Someone else said that need to pre-specify the categories for like
Category. Yep. Yep.
And I think it's through under categories too, but like the unbalanced data set. So like not having all the categories.
Yeah, for sure.
And then there's some others like someone wrote black box. I think mostly for classification, but that probably touched a lot.
Probably most.
Yeah. And that kind of goes along with like confidence in the results. Like by
Make a general category of the black box.
yeah. And then also stakeholders have concerns about like the privacy of videos or things like
In my ethics section. Yep. Yeah, there's definitely privacy concerns. I would add uncertainty. A lot of stock models, uncertainty hasn't necessarily been something that's accounted for, which is really important in our more traditional statistical modeling that we do. And so I think there are a lot of ways to include uncertainty. And again, it's one of those things that takes more work to build it in. It takes more training data, and it takes being thoughtful about the process that you're entering. But there are ways to get at uncertainty. More problems?
that's mostly on what's on the
Okay. Chris, do you want to say something?
Sure. Now, what about the use of whether you use dependent or independent variables for your prediction? Is that important for the AI?
Oh, are you talking about if there's like a confounding variable? Or
Yes. Yeah,
or
like
two
you use
variables?
like fish length or otolith size or otolith area. Or fish age.
Yeah, I mean that's a great question. A lot of the prediction that we do in AI, you say, here's what we're trying to predict, and here are potential predictors, and what makes the best prediction. And so, if you have a lot of things that are very, very similar to each other, you maybe it'll use everything with importance, or maybe it'll just be sort of unresolved. If you don't really get a clear picture. Sometimes it's worth exploring different model configurations where you have fewer predictors versus throwing the kitchen sink at it. Sometimes it is worthwhile to separate things out a little bit more if you have the computing capacity to try different things and see what's a good
Okay.
Yeah.
Thank you.
Sure. Yeah. In some of the work that I do split forecasting. And so I have two model configurations, one with and without environment, because I want to see how my predictions are based on including environmental variable or not, and how much of an impact that has in each year. So is that really significant in some years, or is it not? Is it always important, or is there something else that's more important that shows up when those are or are not included? So I like to play with that a little bit, test things out.
Big problem where like your tree data set gets or the new data that you collect kind of moves into your tree.
Love it. So actually, this is something that I deal with a lot. If there's anyone else who wants to talk about this, I'll give you a second statement before I get overexcited about it.
Would that be like, data set with maybe some hidden correlation between the things you measured, and you randomly subset it, and so it's like training on a data set that's correlated a certain way, but you don't realize it. That kind of thing, or?
I guess the example that I was thinking about was, I mean, I read a book about this, and it was that for example, they were using AI models to kind of predict whether a criminal would re-offend, it had a biased data set, but then if you had a low score or whatever, then you get a longer sentence, for example. But then because they were using this AI to predict the people that they were going to keep arresting, etc., then that future data set becomes contaminated.
Because you're more likely to reoffend in prison.
Yeah, and then it just kind of that was fed back into, and it kind of created like a vicious cycle type of thing. Another example was using like credit scores, like whether people would default on their loans. And so it was like it predicted people from certain zip codes would have a higher chance of defaulting on their loans.
They got higher interest rates.
Then they got and then the data just kind of fed back into the model, and it's like, oh yeah, it's true. People from the zip code have this, those were.
Those are other examples for sure.
I don't know how that applies to fish though.
Well, I mean, so if we're doing prediction, like salmon forecasting or squid forecasting, I do. We have time series data, right? So say I want to take, I want to predict what the catch is going to look like in the 1870s, right? So I can take my time series and I can break it into chunks. I can randomize it. But if I have, say, so here's my catch. Catch. There we go. 1990, 2000, 2010. And so I have, some amount. Some amount for each year, right? And we've got even 1, 2, 1, 2, 1, 2. Right. So if I fully randomize my data, I would, say a couple of data points from each year, and I'm predicting 2020 the catch in season 2. But if I randomize my data in my training set, I might accidentally grab this and put it in my training set here. So when I'm doing my testing, uh-oh, I already know what the answer is. That's not really a good model, right? So for time series analysis, we break things into time blocks. So you want your training data to occur on the first block of time, and then your testing data to occur on the second block. And you know, if it's important to be able to predict one season ahead, you want to build up your your AI or machine learning model slowly so that it's learning, you know, what's the difference between this season, next season, so on and so forth. So you can have cross-validation or polls in your training set where you do set one, this data, 1990, one and two. And then different colors. Second training set here is 2001. Your third training set, all right, is now 1990 through 2000, seasons 1, 2, 1, 2. And so each of these, in the first case, got your first poll, and you're predicting the next season. And then you include the next season and predict the next poll. And then you include that season, predict so on and so forth, to build up your model. So you have temporal data. There's ways to prevent for fisheries examples like this. I'm sure there's other examples for some of these other categories, if anyone wants to throw them out. There's also a different kind of version of data leakage. So for image identification, in their training set, if you say train, you have a specific camera in a specific location, and you're training it to categorize the fish that you pass by, right? And then you try and apply that to a different camera in a different location. Something that's happened in the past is that the AI actually learned the background of camera one rather than exactly what you were asking it to do. And so camera two then doesn't perform as well. This is different background. And so for that, they do augmentation. So you take the training data set from the first camera and you just put different text. Yeah. And I think it's a brilliant solution personally.
I have one example for CSV for AI. An example of it had the limited data problem where only fishing vessels that were, I guess, identified as like slavery or forced labor were ones that certainly had the bias. It was like applying data from like maybe 40 vessels to like 60,000. Yeah, it concerns me. Well, yeah, the way that was.
I read about probably 10 years ago, where some intelligence agency military, I forget what, was predicting who was a terrorist based on cell phone metadata, and it was like the training set had like eight terrorists, quote unquote terrorists, and it was just like, you know, that was
idea, but yeah.
Or a terrible idea.
Or, yeah, maybe not. Maybe not. Yeah. Yeah, agreed. So I think limited data is problematic. And, you know, how much is enough? And does this have actually present a pattern? Or is it just like terrorism from, you know, cell phone metadata? Yeah. I think there's a lot of variability in cell phone use. So that's, you know, it's one of the things that a lot of machine learning tools are not good at are predicting outside of the known zone. So that's one of the big things in machine outside the, and I think that's a concern for us who are in fisheries and conservation and want to do prediction, but we're faced with things like long-term climate change, right? I'm not going to try and predict how many squid there are going to be 2 years from now if they're really highly affected by El Nino cycles, and I don't know what El Nino is going to be in 2 years from now. Or got, you know, long-term change. You've got sort of slow, gradual warming, and if you're trying to predict, you know, something spatial based on what's known, you might not be able to do a good prediction because animals may be moving into unknown zones, places we've never seen them before. And so I think there has to be a lot of careful about that. So there are certainly things that AI is not for, and things that it is for.
I want that. This is not a problem per se, but I think you should go with red.
Yeah.
When should you reach for, like, there's some arbitrary cutoff between like traditional statistical models and like AI ML model.
Yeah.
When and why should you reach for AI instead of a traditional statistical or scientific model?
I have some answers. Does anyone else want to chime in on mine?
I love ChatGPT. Putting it in level that I use a lot. It's very helpful.
Which one?
ChatGPT.
Okay. Andrea, do you want to talk?
Yeah, I think one that jumps out at me is causal inference. You know, we definitely shouldn't be using AI if we're interested in determining causal relationships.
Okay, so no. I almost wrote cobbles like cobblestone. Okay, copying. Perfect. Thank you. Thank you for being here. Whatever works. Yeah, so not for causal relationships. I think for me, the big yes for AI is automating processes that take people a long time to do. That's the big easy. Automating processes. So talked about it. Statistic data, video data, photo data, things that you want to pull specific bits of information out of, but you don't need tens of thousands of hours of things or to have to go through that manually. That's a big reason AI for me. You know, to make people's jobs easier. I used to sit at a microscope 20 hours a week as an undergrad and sort ichthyoplanktton samples. I'm pretty sure we could design a device to recognize those probably more accurately than I could. You know, so I think that, you know, kind of goes under the automating process, you know, a way to do things maybe faster and better. Humans get maybe more accurate from the process.
It kind of goes in there too, but someone online just loads of data.
Yeah, loads of data. Process. Yeah. It lots of time. What about decision making?
I wouldn't.
I would put that under first. I think AI is a tool to give us information to make decisions. I don't think we should outsource actual decision making. In part because of this, you know, bias thing that we talked about a lot. AI is not unbiased, and people are not unbiased. The data collected is not unbiased. Decisions made within the model are important. I think that's all important things to consider. And in the AI workshop, we talked about how humans are much better at making decisions than machines are. So, needs to be, well, better in relative terms. Sometimes humans make very poor decisions. However, I don't think we're ready yet to outsource decision making. Personally, I think it should be a tool for information. Any other stuff coming up on there? I think, part of why I turned to the machine learning methods is because I was trying to predict squid populations, which are really, really hard to model with credentials. And my goal was prediction, which is what AI is designed for in a lot of these, depending on the model. So, if all you care about is doing good prediction, sometimes this is the way to go over a standard. It depends on your question. Depends on out of it. And how important things like uncertainty are to you, and if you design your model to try and grasp that in some way. Or if you just need a point estimate for something, or if you just need a, threshold above or below here. Sometimes AI is really good at that. With John Trachta's herring populations, he had a bunch of different populations, a bunch of different patterns in the stock biomass, and just by eyeball, as humans, we're good at finding patterns and picking them. But this was a good way of saying this population is recovered, this population is not. I think prediction could also be helpful for things that we're augmenting some other piece of work we're doing. So recruitment, for example, is really hard to predict with standard statistical models. Maybe with some machine learning and AI tools, we can do a better job of predicting recruitment itself. That's not to say that we're going to understand exactly what the drivers are, where and why of recruitment, sort of that inference versus prediction trade-off. you can get really good predictions without maybe knowing exactly what's driving that. So
Ian tried that with his salmon, and
yeah,
that's like the best information on recruitment probably for Bristol Bay salmon.
yeah, the salmon forecasting models are pretty good.
Yeah,
But
the AI.
But recruitment, I don't know. Yeah. I don't know. Christine's on. She was doing some recruitment work.
That's also like the time, like it's not a lot of data at the end of the day, right? You have like a 30-year time series of really good data. It's like amazing.
Right.
Compared to thousands.
Right. Christine?
I mean, when we tried it with recruitment, it didn't outperform a linear model was the problem, or the null model, like the previous year's recruitment as the next year's recruitment. The other problem with recruitment was it's serially autocorrelated, and so you need to like do the rolling window trainings. Yeah, okay, sorry. Sometimes it's hard to follow what's on the board from the way.
Oh, yeah, no, it's yeah. And that's actually a really great point that Christine brings up is, you know, machine learning models and AI models tend to be pretty sophisticated. It's good to test those against a really simple model to make sure you're doing better than the basic model. The principle of parsimony. Don't use something more complicated. Make sure you're actually getting. So if a live one model is a better predictor of recruitment than a machine learning model, you know, last year's recruitment predicts this year's recruitment within some bounds. Machine learning doesn't do any better. A lot of effort in a model that doesn't do much better. No, it's not really worth it. And that's a good check as scientists. We're doing this work. Another example in here, I don't know exactly what happy whale is, but there's a lot of marine mammal ID. I don't know if this is the 2.6 or images. Photo ID, yeah. So there's some cool, you know, marine mammal and bird photo ID things out there where based on, you know, a shot of a fin, you can identify down to a specific whale pretty quickly and easily. It's awesome. All right. How's everybody doing? Second. Do we want more of something in particular? Do we want to move on? Fine, I'll wait. Some of it. Go on. I'd love to hear from anyone online some of the challenges that you've overcome in your data or model, you know, working or dealing with particular problems that have to be overcome just by the nature of the work we do. Chris, you want to talk?
Yeah, I have a question again. You're talking about augmentation via, let's say, using camera A or camera 1 versus camera 2. Are you talking about like let's say, like different imaging software, and then you're going to standardize that? Is that what you're referring to? Like if you're going to imaging otolith or?
Right, yeah. So for the augmentation, I'm not an image classification specialist by any stretch of the imagination, but essentially the problem that someone was encountering is that their machine learning model was able to identify what the things that they were tagging and wanted to see in their data with a specific background. But with a different background, it wasn't able to do that identification. And so what they did to solve that problem was to take that tagged data and put a different background on it. And, using a couple different backgrounds, making sure that the machine learning model is learning, the shape of the fish and doing the fish ID instead of IDing a fish based on a specific background.
Okay, I understand. Like say like a dark background that's as long as it's standardized, and then there wouldn't be an issue.
Yeah, I think so. So I think it's sort of the difference between, I don't know, you have a picture here, and in this one you've got, I don't know, maybe some green stuff here, got some rocky masses in here, whatever, and then you've got some fish that swim through, right? And so in your training data set, you're saying, identify this fish, identify this fish, and the model is learning to do that, but it's learning to do that in the context of this fish being with this shape. It's not just this fish alone. When you put it in a different environment, you have fish, but none of the stuff down here, it has a harder time identifying that fish. Does that make sense?
Oh, I see. Be almost like, yeah, I see what you're saying. I understand that. Yes. Try to reduce any type of scatter or pick up any anomalies that would affect the interpretation.
Yeah. Are you thinking in general or for otolith specifically?
Well, I guess otolith specifically, let's say you image a otolith on a dark background and you have, let's say you have areas outside the perimeter of the otolith that maybe like dust particles, like you have it on a shiny background. It picks up on that. So when you image that, you want to make sure that you don't have any anomalies outside of the perimeter itself. I'm trying to say on the background.
Right. Yeah. Yeah. So the background is one thing to think about. The other thing that I could think of maybe for otolith is otolith shape. So say,
yes.
You're going to laugh at otolith, I'm sorry, but
yeah.
You're otolith, right? And
yep.
You want it to say count the rings in the otolith. All right, so you're saying count these rings, but maybe it's counting these rings based on this shape, so that when you have an otolith that's maybe like this and has a little knot and it's broken or something differently, it has a harder time counting the rings because this part is different. So what you want to do is in your training data set, you want to make sure that you have a lot of different shapes of otolith so that that's not a confounding factor in it being able to count the rings.
Right, and hence if you have like two similar species, and you have a big enough sample size, then the AI will be able to separate those species out by a small variance in, let's say, the perimeter of the otolith, or the shape of the otolith. Okay.
Yeah. That's another thing you could do. Say this is, I don't know, this is sardine. Why not? And this is the tuna. Because I have no idea what otolith shapes look like. But you could.
It's pretty
based on
close,
the
nothing on the right. Yep.
you could, based on the shape, potentially train your AI to identify them by different species, based on your thinking. Different kinds.
Great. Thank you.
Yeah, for sure. Thanks for bearing with my drawing skills. Yeah, these are great questions. I love it. Anyone else want to jump in? I'll give it a minute, and then we can talk about some of the resources available, some of the things we talked about at the No AI workshop. Okay, let's do it. We have one vote. That's enough today. All right. Okay. I can't read it. We pulled all our something. You make it bigger. We realized all our data is flawed, so we're not sure about conclusions. So we did lots of math and then decided our data was actually fine. So we trained an AI to generate better data. Exactly. That sounds like the process. Oh, yeah. I put a sticky in the resources. It has the link to Noah's AI workshop. So you can click on that, copy the link, or we can maybe put it in the chat. But there were a lot of really awesome talks. I think a bunch of them are recorded. And you can look at the list of speakers and topics. For me, it was really useful in thinking about the application of AI beyond just fisheries, which is what I do. So I really enjoyed that. So for fisheries specifically, in the AI workshop, Evan Howell, the director of Office of Science and Technology for fisheries, he said doing prediction-based and model selection techniques, cross-validation, rather than inference-based when doing stock assessment forecasts might be a way to go. So thinking about doing model selection techniques based on AI rather than on, say, expert opinion or based on some inference. What do people think about that? But there are sometimes we say we're going to use expert opinion as no additional input for making a decision about, I don't know, weighting in our model or what parameter value to use. Should we be using AI to try and get at some of that stuff?
I can't even wrap my head around how would you train a model to do that?
I don't know. I don't have an answer to this question. That's why I'm asking it.
Well, that falls under decision making, right? Earlier you were talking about that.
Yeah, it could. It certainly could. Rick suggests AI to detect pattern in model residuals. Ooh, I like that. Break my thought.
Mm-hmm.
Coming through. Good answer. Yeah, detecting residuals. That's a great idea. Definitely use it for that. Maybe we think about something like doing predictions for time-varying growth parameters. You have a fish that has time-varying growth that depends on certain conditions in the environment. Do we try and use AI to do prediction of that? Of what we think those growth parameters should be? Oh, Andre was on. I thought he had an answer for that question.
I think he's been,
Is he multitasking?
well, he was, but I think he was also dropping in and out on his. Ian Taylor suggests, it seems hard to train AI for model selection when we have no idea what the right model is most of the time, and our sample sizes are low.
I agree. How do we tell an AI how to do it? Yeah. Good question. They only do what we tell them to do, right? Yeah.
A big part of my hesitancy, I guess, with AI and fisheries models is kind of, have all these data, we still have no idea what the true state is, right? And so could be way off base anyway. And so we just throw more throw more non-parametric at it. It's kind of like we don't know what to prove. Yeah. And it's kind of garbage in, garbage out, right?
Yeah.
Not saying that all our data are garbage, but we just don't have very much compared to what these AI models are used, at least for assessment.
Yeah. So maybe a question is, we use it as an alternative model to comparison. So we predict, biomass of polyps. That's the most data rich, one of the most data rich things we have. And compare that to the traditional stock assessment, see how close or how far apart they are. We don't know the absolute true state. We have alternative comparison. I'll sign Jimmy and Ellie up.
Catherine Doring suggests, is there a role for AI in ensemble modeling, perhaps post-processing? I have no idea.
Yeah, maybe. I mean, that's what ensemble modeling is, right? We do a bunch of different models and compare the results. Yeah, the possibility.
Ian Taylor says, on the other hand, if we can have AI recognize fish ages ages well enough, we can just do a census using AUV, not bother with stock images. Sorry. Okay. Sorry. Ian Taylor says, if we can have AI that can recognize fish images well enough, then we could just do a census using AUV, not bother with stock assessments.
Whoa, what a radical idea. I love it. Yeah, that'd be cool. Just have arrays of cameras across the entire ocean floor or floating mid-water. Might impact fish behavior, but that's a cool idea. Yeah. There you go. I mean, that would certainly, that'd be certainly be interesting to explore, particularly in closed environment areas. Starting point. Maybe that's what we'll do. But they're hard to assess anyway.
Throw all our computers away. All right, that's it. I quit.
Just let the machine do it. Uh-oh, I'm gonna be in trouble after this. See if there's any more comments for a second. So two of the big themes that we talked about in the AI workshop were working towards AI-ready data and explainable AI. So, what is AI-ready data? How do you know what fisheries? So, I mean, for images, you might want your image already. You have a ready-made set. Okay. I know, this is the fun part, huh? Maybe some decision trees. I would want to see things to do to your data prep based on the type of data that it is. That's our prep choices. So, for example, we had that, temporal autocorrelation. Doing that in blocks for randomized.
Probably goes along with it, but like proper metadata. That goes for all data, not just AI-ready.
We'll put that in really big letters. Metadata. Yes, please. Metadata for everything. Okay. Annotated. I'm going to add plus accuracy. Okay, accuracy, yep.
Says images with no magnification.
Yeah. So that goes in the metadata part.
Something I've been struggling this week, not knowing like coordinate references.
Yeah, ERS. Coordinate reference systems. That's the big one. Yep.
One says FAIR, which is the acronym, findable, accessible, interpretable, and readable.
I always struggle with that.
Yep. There. Findable, accessible, interpretable, and reusable. Yeah. So where can we find our data? Big first question. And I mean, to be honest, a lot of the data that I are scattered all need a central place for that? Or does that having a central place not fit all kinds of data? Accurate, right? Accessible, yes. Being able to actually get the data. Interpretable. Maybe interoperable. Yeah. And reusable. Right. So if we have data posted online somewhere, but then it gets updated or they find errors or it changes, how is that documented? Is that part of the metadata process? Is there a change log? That's yeah. A little action online. Is it better to have completely raw data or somewhat processed data? Right? Do you want fish counts or do you want catch per use effort? Or do you want both? Everything. Right. So how is the data made available? Has it been processed? Has it not been processed? What does that data processing look like? Is the code accessible? Is there documentation? I think this is true across data, not just for type data.
What you were saying about like bias in like using biased data. I mean, I guess obviously then you would want unbiased data. But like, yeah, data that, I don't know, thinking about like how you would get that, you know, like being really intentional about data gathering.
Mm-hmm. So not just the data processing, but the data gathering. How the data is gathered, how they get into the system, how they're processed after that. A lot of metadata. And also, you know, who did the data gathering and who's it attributable to? Who, you know, who did what work? And by using this work, do you need to list them as an author? Or, you know, is this made available to use however you will? You know, that's an important thing too. People make data available, but sometimes it's work really hard to gather that data or to process it or provide it into a usable format. And so being considerate of, you know, how we use someone's data. Unless it's federal data, then it's free for all. All right. How about explainable AI? Great. Perfect. So essentially, can you explain what you did? Somebody, can you explain your model, explain your data, explain yourself? That's God, right? Yeah. How much? I guess part of it, this is how much of the black box do we need to understand? How much of it is a tool that it's okay to just use, and how much do we need to dive in and say, I need to understand how this black box works? Also, I think, what is your question from the outset? And are you answering that question? I think that's true for science in general, but it's important to keep that in mind. You know, if you're, in my case, I'm trying to predict squid catch because that is all the information that I have. I don't have information on total biomass. And so that's not something I can predict. You know, it's important to me that that's clear in the work that I do. Yeah. Yeah.
Documenting them.
Yep. Okay, yeah. So if you have a complex AI model that's making some decisions or, you know, identifying specific things, have it be specific to a certain task rather than have it try to do everything all at once. I'm guessing is what that means. Yeah, accuracy, precision, validation, importance, uncertainty. You know, I'm seeing a lot of things in here that remind me of a discussion we had in the AI workshop about making sure you have your intent and your choices included in your documentation of what you've done. Right. I mean, we've covered pretty much everything I had prepped. So if anyone wants to circle back to anything or talk about something specific, change gears a little bit, please feel free to jump in. Or go back to your life, that's fine too.
I have a question from Jen. Would there be a good person or group to get in touch with about an effort being worked with NOAA and CEI, in parentheses, Barracuda/Aquaview, that could extend to the fisheries and also to discuss possible collaboration?
Okay, so sorry, the question was there someone like a point contact at NOAA?
Yeah.
Yeah. So for NCEI in general, or
then I'll also unmute you. If you would like.
the contact I would suggest is a another vent, but I want to make sure I get the right one.
So am I coming through clearly for you?
Yeah. Yep. Yeah. Go ahead.
Okay. Yeah. So we're working an effort under NCEI right now. It's being spearheaded out of the University of Southern Mississippi. And the goal of our effort is to help curate the data that they've collected and archived to make it, as somebody mentioned out before, more fair, findable, accessible, interoperable, reusable. And then the company that we're with also does a lot of AI, so we're building in capabilities to add annotations into the data to then pair the annotations with the data with all of the metadata and source tracking. We're only currently working with the data that they have at the moment, which is still a significant amount of data, but we're getting to a point where we're getting ready to actually expand that out and make it more available for people to start developing their data to fit that model to help make that data searchable. So we're looking to see if there be someone or a group of folks that would be ideal to get in touch with about collaboration along those lines.
Yeah, that's a great question. And I'm hopeful that some people are on who can help with that. My initial recommendation is Ben Richards, who sort of leads a monthly meetup on AI in NOAA, would be a good contact. There's also FOSS. It's the Fisheries One-Stop Shop hosted by NOAA. They have a lot of data that they host on there. And I think that's Office of Science and Technology. So if someone from OST is on who wants to give a little info about FOSS, F-O-S-S, and if that would be a good fit for your data, I think that's a great question. I don't know.
So, can you please repeat?
We can hear you. Oh, did we lose somebody? Chandra Shakar, are you trying to?
No, can you please repeat?
Oh, I hear you. I don't hear anything anymore. Okay.
Oh, was it the song?
That's okay.
Oh, okay. Just asking if we could.
Repeat the question.
Mm-hmm.
Okay. Yeah. So the question was, if you're a group, I'm going to generalize here. If you're a group that's making AI-ready data, where should your data go? Was what I voiced the question. That's a great question. And so my recommendation would be to reach out to Ben Richards at NOAA, who leads our monthly meetup for AI and NOAA, or to talk to the Fisheries One-Stop Shop, FOSS group. They host a lot of the NOAA fisheries data on there, and so that would probably be a great spot for fishery data. Based on my limited knowledge of the system. But fisheries data is posted in a lot of places online. And I think FOSS is trying to aggregate things into one place where possible. What else? I have any more questions online? Oh, great. Okay. We've solved it all. Everybody's ready to go out and do AI-ready work. I love it. All right. Well, I'm going to say thank you so much for everyone who came today. Please feel free to send me emails. and love having these discussions and being nerdy about it. So thank you very much. Thank you.
Thank you, Caitlin, and thank you to everyone else online. We're going to end it here, and we will see you in 2 weeks for another think tank.
And thank you so much for setting everything up and allowing me to